So before we graph this piecewise defined function, I first would like you to evaluate the function for some different x values. So part A, I would like you to find f of 2. So remember, this is basically telling you that x is equal to 2, and I'd like you to find the corresponding y value. When x is equal to 2, what does y equal? Well, normally you would say plug in 2, but since it's a piecewise function, and this has two pieces, remember, here's my first piece, here's my second piece, I have to decide which piece I'm going to substitute x equals 2 into. And I won't know that until I take a look at where x equals positive 2 belongs. So I need to take a look at my domains here. My top domain is when x is less than -3, and my bottom is when x is greater than or equal to -3. So where does x equal 2? Where does 2 belong? Well, hopefully you realize that 2 is greater than or equal to -3, so 2 belongs into the bottom domain, which means I'll substitute 2 into the bottom piece, or the second piece in this case. So substituting x equals 2, we'll have negative quantity 2 plus 2 squared plus 3. So 4 squared is 16, negative 16 plus 3, and my output will be negative 13. F of 2 is equal to negative 13. So B is asking for f of negative 3. So x is equal to negative 3. So again, look at your top and bottom pieces, looking at the domains to see where does negative 3 belong? Well, because the bottom domain says x is greater than or equal to negative 3, it belongs in the bottom domain. Therefore, I will substitute negative 3 into my second piece, or my bottom function. So negative quantity negative 3 plus 2 squared plus 3. Or negative 1 squared, which is positive 1, times negative 1 plus 3 yields a positive 2 output. And part C, f of negative 4. So x is equal to negative 4. So again, we're back here looking at my two pieces. Where does x equals negative 4 belong? And negative 4 this time is smaller than negative 3, so it belongs in my top piece. So we want to substitute x equals negative 4 here in the top piece, which is kind of interesting because there is no x value, or variable here, I should say. But remember, my top piece here, the first piece of this function, reads f of x, which is the same as y, is equal to 4. Remember, that's just a horizontal line. That's saying that no matter what the x value is, the y value will always equal 4. So my output here is just positive 4. When x is equal to negative 4, my output, my y value, is equal to positive 4. Now part D asks us to graph the function. So first, make sure that you're doing this in pencil, not pen, with a good eraser, because if this is your first piecewise function that you've ever graphed, then I'm going to show you how to graph each piece and then erase what you don't need. So an eraser is going to be important until you get the hang of this. So we'll take a look at our first piece. And you don't have to be writing down the individual pieces, but again, I'm going to show it this way in case this is your very first piecewise function you've ever seen. So again, we would read this, f of x, y is equal to 4. In other words, my first piece is y equals 4. So we want to graph that. Well, y equals 4 is just a horizontal line. So here's the entire line, y equals 4. So we've done our first piece. It's like you can check it off. Check, we graphed y equals 4. So now we read from left to right. Now we're going to move over here and take care of this domain restriction, because we don't want the entire line, but only the piece of the line where the x values are less than negative 3. So if we go to x equals negative 3, and we go to our line here, we want the piece of this line where the x values are smaller than negative 3. That means I would want to keep the left-hand piece of the line. That's where the x values are smaller than negative 3. And then get out your trusty eraser and erase this right-hand piece. So we still have my piece y equals 4, but we only have the portion of the graph where y is less than negative 3. But then, because the sign here is a less than, not less than or equal to, We also need to erase and adjust what's happening right at negative 3, because that needs to be an open dot, since we're less than negative 3 rather than equal to. And you just successfully graphed the first piece of this piecewise function. So now we go on to our second piece. So the second piece of this function, again, f of x is y. So y is equal to negative quantity x plus 2 squared plus 3. So if you need help graphing this second piece, if you still are kind of working in stages, then I would get out a sheet of scratch paper and I would list your parent function and list your transformations. But as you get with a little more practice and get more familiar with these, hopefully you'll begin to graph these without having to graph all of the intermediate steps. For example, I hope that you know this is a parabola for the parent function, y equals x squared, that it opens down because we have a reflection over the x-axis. It has been shifted left 2 and up 3. So I'm going to go ahead and graph my entire parabola, and then we'll go and erase the piece that we don't need. So I'm going to go left 2 and up 3. So here's my vertex. And then this parabola opens down, and it's a standard shape. So from the vertex, I'm going to go right 1, down 1, since 1 squared is 1, and left 1, down 1. And then from that vertex, I'll go right 2, down 4. 2 squared is 4, and left 2, down 4 from the vertex. And if I have room, and I do, from the vertex, I'll go ahead and go right 3, and then count down 9. Which puts me down, looks like here. What was that? Negative 1, negative 2, negative 3, 4, 5, down here at negative 6, it looks like. And then from the vertex, left 3, down 9. And remember that parabolas are nice and symmetrical. So this would be the entire graph, the entire parabola. But as you get started, I recommend go ahead and graph the whole thing, and then we'll erase what we don't need. Now, I can check this off my list. I've graphed the second piece, and so lastly I need to come here and make sure that I'm including the correct portion. Now, if you were to stop right now, I would know that we are wrong because what you have graphed here, or what we have graphed, does not pass the vertical line test. And remember, these are piecewise functions, so your final result must pass the vertical line test. So I want to keep the piece of this parabola where the x values are greater than or equal to negative 3. So again, let me do this one in a different color for you. I'm going to go to x equals negative 3 and go to my graph. That would be this point right here where x is negative 3. And then I have to decide whether I want to keep the left to the left of this or keep to the right. Because I want greater than or equal to negative 3, I'm going to keep all these x values to the right, which means I'm keeping this piece of my graph, keeping the right-hand side of the graph, and then I will come in here and erase the left-hand side of the graph. And then again, I have to make that decision about what's happening at negative 3. But because I had greater than or equal to here at x equals negative 3, I do want to include that point, so that would be a solid dot where x is equal to negative 3. And you just graphed your first piecewise function.